Let's imagine we're in the kitchen, we're cooking, and we decide to ask ChatGPT, what's the right temperature for chicken? And it gives you something that sounds totally standard and confident, but it's actually just wrong. If you've already cooked chicken before, you might know the right ballpark and be quickly able to push back. But if, like me, you've never done it before and didn't already know the answer, you'd probably never question it. That right there is the main danger. So what is an LLM? LLM stands for Large Language Model, and it's just the name for the actual thing that different companies like OpenAI, Anthropic, Google, etc. offer. An LLM is like coffee, whereas ChatGPT, Gemini, and Claude are like Starbucks, Peet's, and Dunkin'. Under the hood, an LLM is effectively just a model that has been trained on massive amounts of text data to predict the most likely next word. I'm going to scroll down to this drawing right here, which sort of explains this. The LLM is almost like a pseudo brain that has somehow seen and read everything on the internet and all the books in the world. This does a few things for us. First, it's an incredibly useful resource because it makes a vast breadth of information greatly more accessible. With the internet or Google search, we need to understand what to search for. We read one article, find an important keyword, and then search that to find the next relevant article. With an LLM, we can delegate that intermediary digging work. Instead, the LLM acts like a librarian who already knows where all the information that I need is and can point me to it directly. Together as a world, we have built up lots of artifacts of knowledge. Lots of it exists on the internet and others in physical books. LLMs have become this way to consolidate all of that information into a single place. Then we as humans can interface with it by asking questions. Something like, why does hot air rise? The LLM then looks across its breadth of knowledge to pattern match and return an answer based on the most likely next words. It might look like the LLM is thinking, understanding, and formulating an answer, the same way that we as humans do. But in reality, it's mostly probability. It compares the input question against all the information it has ever seen and predicts what is most likely to come next. All the articles it has consumed about hot air rising will elevate as close matches, and therefore it gets us back an impressive answer. So the key is it prioritizes generating coherent and plausible sounding text over factual accuracy. In fact, it has no concept of accuracy the way that we do. If it is trained on or fed a bunch of articles that say 2 + 2 actually equals 5, it will confidently say 2 + 2 equals 5, because it has no way of knowing that is incorrect. It only knows that 2 + 2 is usually followed by 5 based on its training data. This is exactly what introduces confident inaccuracies, or as they're often called, hallucinations. So that's hallucination, the model confidently filling in gaps with plausible sounding nonsense. But there's another way these models can be wrong that's worth mentioning. The output is only as good as what it was trained on. So if the internet is full of articles where a CEO is assumed to be male, the model actually picks that up. It's not necessarily making something up exactly, but it's reflecting a pattern that exists in the data it was trained on, which in some ways is actually harder to catch because it can sound totally normal. We'll dig into this more in a future video, but I think it's really important to keep in mind when we talk about inaccuracies. So now that we know this happens, what should we do about it? Well, I think the first piece is slightly adjusting the way that we think about LLMs. Talking to ChatGPT is not necessarily a replacement for Google search. It's more like having access to a smart and tenured colleague who, like any human, can still make some mistakes. Absolutely fantastic for a quick gut check on an approach or initial exploration, but not a source of truth. So if you're working on anything even remotely high stakes where the cost of error is high, please be vigilant and make sure to verify the outputs that you're receiving. It's also important to keep in mind that confidence does not equal accuracy. Remember, the model has no understanding of factual accuracy the way that we as humans do. It only predicts based on its training data. So if the method of verifying is asking, "Are you sure?" that validation is actually not as robust as it might seem, because the model will often just double down with the same confidence and say, "Yes, I'm absolutely sure." In fact, it can be quite difficult to get some models to even respond with "I'm not sure," as opposed to a made-up answer when they actually are unsure. Exploratory or repetitious and tedious work, on the other hand, is a fantastic use case because it can speed up the initial startup process without risking high-stakes inaccuracies. All right, that's all for me today. I want to keep these videos as accessible as possible. I believe AI is becoming part of everyday life very, very quickly. And most of the content that I've seen out there sort of assumes you already know the stuff that we've been talking about in the past few minutes. I think that gap is real and it really matters. I want to help bridge it. So if this was helpful, please follow along. And if it wasn't, please let me know. If you have any feedback or ideas, I'm happy to incorporate them. Next video, I plan to dig a bit deeper into how to choose which provider and which models to use and how to actually take advantage of these tools in your daily life. Thanks so much and see you then.